Example 10, and it says find the error between the curve y is equal to x cubed minus 2x squared minus x plus 2 and the x-axis for values of x between minus 2 and positive 3. So one of the first thing we want to do is to draw a sketch of this curve, all right? And the basic reason for that is that we want to identify regions within this range, regions of the graph which is above the x-axis as opposed to regions which are what? Below the x-axis. So let us start by determining the x-intercepts. Now the x-intercepts are the roots of the polynomial, and the roots would be the values of x for which the polynomial is equal to 0. So we're going to start up by saying that x cubed minus 2x squared minus x plus 2 is equal to 0. All right, so one of the first things we need to do is that we need to factorize the cubic polynomial, and to do that we have to first use trial and error to use trial and error and the remainder theorem to identify a linear factor. All right, so let's try different values of x. I'm going to start off by trying when x is equal to 1, this is going to be 1 cubed, or I could say the remainder which is, let's say, f of 1 would be equal to 1 cubed minus 2 times 1 squared minus 1 plus 2. All right, so this would be 1 minus 2 minus 1 plus 2. All right, and this is equal to 0. Now, if the remainder comes out to be 0, it is because x is equal to 1 is a root. And if x is equal to 1 is a root, x minus 1 is a linear factor. Now, if x minus 1 is a factor, I can now divide the polynomial by x minus 1 in order to obtain the cubic factor. So I'm going to have x minus 1 into x cubed minus 2x squared minus x plus 2. Now x goes into x cubed, x squared times. So x squared times x is x cubed, and x squared times minus 1 is minus x squared. So we're going to subtract. Now when we subtract, we're going to end up with x cubed goes, and this become, and then you have what? Minus 2x squared minus x squared, which is minus 2x squared plus x squared, which comes out to be minus x squared. Now x goes into minus x squared minus x times. I can bring down this minus x. Now minus x times x is minus x squared, and minus x times minus 1 is positive x. Now if I subtract, the x squared is going to go, and then you're going to have x minus x, which is minus x, which is minus 2x. Then I bring down the positive 2. Then x goes into minus 2x minus 2 times. Minus 2 times x is minus 2x. Minus 2 times minus 1 is plus 2. All right, and of course, when I subtract these, I'm going to end up with 0. So therefore, the polynomial which is x cubed or the cubic equation x cubed minus 2x squared minus x plus 2 can now be written as x minus 1 into x squared minus x minus 2 is equal to 0. All right, so now to finish this, I need to just factorize x squared minus x minus 2, which is not difficult. X minus 1, x minus 1. All right, and of course I have to put x here and x here. 2 here and 1 here. This is negative and this is positive. That's equal to 0. So therefore, x minus 1 is equal to 0. Or x plus 1 is equal to 0. Or x minus 2 is equal to 0. Therefore, x is equal to 1. X is equal to minus 1. And x is equal to 2 are the roots, which are the x-intercepts. All right. So now I have my x-intercepts, all right, which is a really good start in terms of gathering information to do the sketch of my graph. So one of the next thing I can go after is I can try and obtain the turning points. All right, so I'm going to try and get the values of x at the turning point, using, of course, that at the turning points, dy by dx, at the turning point, the maximum or minimum turning point, dy by dx is equal to 0. So I have y is equal to x cubed minus 2x squared minus x plus 2. Then I'm going to differentiate. Dy by dx would be equal to 3x squared minus 4x minus 1. Now, at the turning points, all right, we could probably try doing some of the work here before we turn to the next page. All right, so at the turning points, so at maximum and minimum, dy by dx would be equal to 0. Therefore, 3x squared minus 4x minus 1 is equal to 0. If you look carefully on this equation, you recognize that I can't solve it using the method of factorization, because essentially there are no two factors of minus 3 that can give me minus 4. So if it can't be factorized, I'm going to have to use the quadratic formula. All right, so using the quadratic formula, I have what x would be equal to. Before I get to that, this would a would be equal to 3, b would be equal to minus 4, and c would be equal to minus 1. Now, x would be equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Let's put in our values. So x would be equal to minus 4 plus or minus the square root of minus 4 squared minus 4 times a, which is 3, times c, which is minus 1, all over 2 times a, which is 2 times 3. So therefore, x would be equal to 4. Negative times a negative is a positive. plus or minus the square root of 16 plus 12. And this is all over 6. So x would be equal to 4 plus or minus the square root of 28 over 6. Now, 28 is the same as saying 4 times 7. The root of 4 times the root of 7 is the same as saying 2 root 7. So x would be equal to 4 plus or minus 2 root 7 over 6. If I divide both the numerator and the denominator by 2, I'm going to end up with x is equal to 2 plus or minus root 7 divided by 3. So the values of x at the turning point are x is equal to 2 plus the root of 7 over 3, and x is equal to 2 minus the root of 7 over 3. All right, let's continue. All right, so we have the values of x at the turning point. And as I said before, the two values of x are x is equal to 2 plus the root of 7 over 3, and x is equal to 2 minus the root of 7 over 3. So this is x is approximately equal to 1.5, and this is x, which is approximately equal to minus 0.6. So I have the values of x at the turning point. I need to get the values of y. So I'm going to say when x is equal to 2 plus the root of 7 over 3. Yep. When x is equal to 2 plus the root of 7 over 3, y would be equal to 2 plus the root of 7 over 3 raised to the third power minus 2 into 2 plus the root of 3 over 3 square minus 2 plus the root of 3. All right, so I'm making errors. All right, so let's just go back a bit to remove some of these errors. So this shouldn't be the root of 3, it should be the root of 7. So it's the root of 7 over 3 square minus 2 plus the root of 7 over 3 plus 2. Now, if you have a really good calculator, you can just put this in the calculator and press equal, and y is going to come out to be minus 0.6. So one turning point is x, which is equal to 2 plus the root of 7 over 3, which is approximately 1.5, and y, which is equal to minus 0.6. So 1.5 minus 0.6 is a turning point. All right. So next I'm going to say when x is equal to 2 minus the root of 7 over 3, and this is approximately minus 0.2. All right, I'm going to have y is equal to